Hey guys, how's it going? This is Siri and I'm back with another PyTorch video. And this actually isn't going to involve PyTorch as much as our other videos did. But we are going to be covering a topic that might be of interest to some of you guys. And this is loading volumetric data. So we're not going to be doing any, neural network stuff with it just yet. Or not in this video. We're just going to be talking about how to load it, so it should be fairly quick. Okay? And fun fact, I'm not actually going to be loading in a real image, or actually volumetric data. I'm not going to be loading in a piece of volumetric data or a sample. I'm just going to show you the steps that you would use to do that, because I didn't actually download anything of that type just yet. But let's get this conceptual thing down about what volumetric data is, and where we might see it, and then let's talk about the implementation. Okay, so if you've watched the video on working with images, then you know that, or if you just happen to know this, you know that we represent images using just numerical values, which actually represent the different pixels. And so we have different intensities. So one pixel might be 3 values, showing the different intensities of the different colors. And if it's a grayscale image, then you would only have one value associated with a pixel. And so, yeah. Okay, but sometimes our data isn't going to be 2D like that. Sometimes it's not going to be images and, just have a height and width and only have the color channel to consider. Sometimes we're going to have 3-dimensional data. And what does that mean? Does that mean just a regular image with a color channel? No, that's not what I mean. What I mean is that our data is literally 3D. Our image is 2D, right? Because it has a height and a width. But, some data, like maybe medical imaging or CT scans, they're 3D. They scan the entire body, and how you go through the through that thing, and it takes slices of images through your body from head to toe, and that's 3D because you actually see, when you see that 3D representation of, your organs and whatever. And it's different from an X-ray, because an X-ray it also is 3D, but the way we see it in front of our eyes is that's a 2D projection of our 3D data. Okay, so in our CT scan, you'll have, I'm just picking a CT scan. You can have other types of images of different domains that are also 3D. You could take some stuff with a depth camera and things like that. And I think I mentioned in my other video, you could have temperature and other features, whatever you want. So when you talk about CT scans, however, you have these cross sections of your body. You have different cross sections. So if you have your body, and then you take a cross section of this part, a cross section of this part, and so on, just to get a full picture of what's actually going on. And so, however, these are typically grayscale images, so they're not color. So you're not going to have 4 overall dimensions, which are just the 3 of your regular 3D data and the color channel. No, because it's a grayscale image. Actually, you might have 4 dimensions, but that color dimension is going to be 1 instead of 3. Okay, so since it only has 1 intensity channel, the third dimension is actually density, because how you have, if you have a grayscale images, the different intensities, if it's darker or lighter, that shade of gray represents the density, but if you were, being even more specific, it also entails the atomic number of whatever whatever substance we're dealing with. But that distinction is not really necessary because we're just gonna, the units don't really matter here. Because when it goes into the model, it's just numbers, and we're just crunching those numbers using the computations that we've specified, or the layers that contain the computations that we want. And we would call this volumetric data. You not only have a height and width, but you also have a depth of the real data that we're talking about, not for some other batches or color channels. No, the actual data that you have at hand. It's just a regular 3D that we all know and love. It's the physical representation of that, of those numbers. And so we would call this volumetric data. And it would be represented as a 3-dimensional tensor, putting the other attributes aside. Okay, and so the way we would read this data is using the same imageio module that we've used in our previous video. And the reason why I used imageio is because, once again, we would stay consistent with the tools that we're using. So instead of using like torch vision for one, torch audio for another, and let's just keep it consistent and learn the basics for now, and then learn how to use those different libraries and those different modules in each one a bit later. Okay, so the way we would do this is instead of using the im read like we did in our with our images, we would use the vol read function. And you would expect this reads volumetric data. Okay, so let's do that. Let's import imageio. And let's say our path is just some path. Okay, and this is what I mean by I don't actually have it downloaded yet. So maybe if we do a more complex example, I'll actually download it and go through the different steps with you, but I don't actually have it downloaded. If you want, though, you could search up DICOM images, and you can DICOM is just like the file type that we're going to be dealing with, and we'll talk about that more in a second. But you could search up those images and download it yourself. And you can also visualize it with Matplotlib if you wanted to. But we're not going to be doing that right now. So let's say vol array, so our volumetric array, and let's say imageio.volRead is dir path, and what's the file type? Okay, let's just say DICOM. And so what this is, if you've never heard of it, it's digital imaging and communications in medicine. Okay, that's the type of file that we're dealing with. Maybe it would be helpful if I actually typed it out. Okay, digital imaging and communication. Okay, let's copy it up here. Okay, communication in medicine. Communications. Okay, so DICOM files. Okay, great. Let's check out the shape. Oh, I didn't import it. Yeah, this is not gonna make any sense because some path doesn't exist. So unfortunately, we're not gonna be able to run it. Okay, so let's clear the output. But you get the idea. Okay, so maybe it's probably gonna be. So if we have 99 images, and we have 512 by 512. Another point we should note is, we already covered this, but okay, so the color channel is the third dimension that I'm talking about, the third physical representation, which represents the density. So don't get confused that you only see 3, because first of all, it's not finished. And second of all, let's use unsqueeze to make some room for that. And so what shall we do? We shall say vol is equal to torch.from numpy. Okay, vol array. Array. Let's convert it all to a float, just for ease. And let's say vol is equal to torch.unsqueeze. This is the dimension. This is the input. This is the actual input, and the dimension along which we want to do this is not along. I mean, the dimension which we want to add this extra dimension is the first one, because that's where the color channel is supposed to go. And I mean, for some reason it works like this. Another step you could add is to actually, convert this to a numpy array. So step 2 would be to convert that to numpy array, and then you can do this, right? And so what you would do is just import numpy as np, and you would say vol numpy is equal to np.array, and pass in your vol array. And then do that. Okay, so what does unsqueeze do? Unsqueeze actually adds in an extra dimension of 1. So like how, so it's actually a pretty common requirement to add not to add like dimensions of unique values or particular values, but just 1. So like 1 by there's a difference between just 3 elements and a 1 by 3 tensor. There's a difference between 3 by 2 and 3 by 2 by 1, so we need the color channel to be along the first dimension. We need that color channel to be the first dimension, and that's the index. The index of the first dimension is 0, right? And we want to do this to vol, because we defined it here. And we want it to be 1 because it's a grayscale image, and which represents the different densities in the body, okay? So the color channel represents the density. So like I said, like how light or dark or how gray it is, right? Okay, so that's what we're doing here. That's a basic idea of how you would load volumetric data for one image. It would be different if you had different batches. A batch of like multiple samples. And so you would do the same thing as we did in our images, working with images video, except it would be with volumetric data. So overall, it's not that different, except, if it's like, you would really need to understand what that third dimension is and how it's relevant to the particular domain that you're working in, because it might have a significant impact on like what layers you choose, what modules you choose, and how you choose to structure your network or whatever, right? So it's important. I think that's basically it for this video. So thank you so much for watching. I hope you learned something new today, and don't forget to like, comment, and subscribe.